Welcome and thank you for joining us for today's webinar, Why Modern Systems Require a New Approach to Observability. My name is Raleigh Gould and I will be moderating today's event. Our featured speakers are Steve Hendrick, Research Director at Enterprise Management Associates, and Daniel Spoonhauer, CTO and co-founder at Lightstep. Steve has over 20 years of experience as an industry analyst and 10 years of experience across a variety of application development roles. At EMA, he specializes in application development and deployment topics. Spoons is a co-founder at Lightstep, where he builds performance management tools for deep software systems. Previously, Spoon spent almost 6 years at Google, where he worked on developer tools as part of both Google's internal infrastructure and cloud platform teams. And before I hand things over to today's featured speakers, I wanted the audience to know that we will be concluding today's event by taking your questions. You can log them anytime by using the Q&A functionality. Also, today's event is being recorded, and you will receive a follow-up email from EMA later today that will include the on-demand playback, a PDF of the slides, and additional resources on Lightstep. So I hope you will check that email out. And now I'd like to go ahead and turn things over to our first featured speaker, Steve Hendrick. Steve?
Hey, Raleigh, thanks for the introduction, and it's great to be here. I'll be kicking this webinar off, and I want to begin with a handful of slides. The first one that gives us some context on what observability is all about, and then a couple of slides that we'll go through and provide some empirical data to showcase just how important observability is. So anyway, in this particular slide, I'm sure everybody would agree that application development and the manageability of applications has changed significantly over the last 5 to 10 years. You know, when EMA looks at how application development intersects with manageability, we see 4 key tenets. Cloud-native application development, of course, on the left here, embraces decomposition of a product into projects and tasks while maintaining separation of concerns. Abstraction represents and reflects the ability of more powerful tools and frameworks and services that makes development both easier and faster. And the result are applications comprised of many microservices, but at the expense of more complex application topologies. These deep systems, as they are called, are easier to maintain, but are more challenging to orchestrate and to manage. Now, cloud-native applications and deep systems are challenging to manage in production, and the asymmetric nature of how these applications scale up and down is what makes them so complex to manage. So manageability solutions for deep systems must take this into account. And the secret to manageability is to make it a data-driven process. Peter Drucker said it best when he said that what gets measured gets managed. But manageability also needs to be about policy, because policy determines what actions are taken based on the data. Now, this combination of data and policy is what defines observability. Now, while we have already touched on the value of data, it's important to recognize that the variety, volume, and velocity of data have a huge impact on how we both develop and how we manage applications. Finally, there's innovation, which is responsible for the rapid evolution that we have seen in cloud-native computing and manageability and how we leverage data. Innovation is what drives continuous improvement, and innovation is responsible for open source software. It's been responsible for the development of APIs and a host of new capabilities beyond what I've already mentioned here, and will undoubtedly change and increase as software markets move forward. So these tenets together help frame modern application development and management, and key terms that you see here, including microservices, deep systems, observability, open source software, and APIs, will factor significantly into today's discussion. So now let's take a look at some recent data that helps us understand exactly how application development is changing. Now this slide looks at how approaches to application development are changing. This was a single response question where large enterprises were forced to choose one of the following three responses. The first response was custom application development for internal use only. The second was a blend of app dev to support both internal and external needs. And the third was essentially the digital enterprise, where custom application development was pervasive across all aspects of things that matter in the enterprise. Now, the changes that we saw in just over 1 year, from 2018 Q2 through 2019 Q3, are shown on the right-hand side of the screen here. And this includes a 43% decline in large enterprises whose software development was internally focused, a 48% increase in enterprises focused on internal and external software development, and an 11% increase in the number of enterprises where software development was pervasive across all activities. So in a very short period of time, we see a remarkable transition taking place from the standpoint of how large enterprises view the value of software. Now, when we asked large enterprises to identify their top 3 DevOps objectives in 2018 and again in 2019, we also saw seismic shifts. In 2018, the priorities at large enterprises, and this, of course, is shown by the gray bars here, were to improve agility at 25%, application performance at 18%, and a speed of software delivery at 16%. By 2019, the priorities were to improve the quality and reliability of applications at 29%, improve the speed of software delivery at 22%, and improve the customer experience at 2018. Now, improving the speed of software delivery was a common thread. It made the top 3 in both surveys, but it did increase in importance from 16% to 22% in 2019. Most large enterprises do see themselves as agile, so that objective from 2018 has largely been addressed, even though it continues to be a work in progress. But today's focus on improving the quality and reliability of applications, as well as the customer experience, depends heavily on observability, because observability is a path to continuous improvement. Now, when we looked at reasons for using operational analytic tools, we see a bifurcation of responses, those above 40% and those below 40%. And the most important reasons for using operational analytic tools, those above 40%, as you can see here, included avoiding software failures, improving performance, improving quality, eliminating delays, and improving staff productivity. So observability is once again key to addressing all of these requirements. Now, one of our objectives in the DevOps surveys that we do annually is to understand the DevOps market segment penetration and how it changes over time. And this chart shows 19 functional market segments associated with the DevOps pipeline, and changes in penetration based on current and projected data for 2019 through 2021 enables us to estimate growth rates. Operational analytics has the 3rd highest growth rate here, which is expected to exceed 40% in 2020. And operational analytics is one of several ops-focused markets that are experiencing high growth. And our longitudinal research shows that investments in DevOps is transitioning from dev-focused markets back in 2018 to ops-focused markets as large enterprises seek to complete their DevOps tool chains. So now that we've seen some empirical data on how application development is changing, I'd like to bring Spoons into the conversation and talk about how he sees application development changing and the implications of these changes. Spoons?
Great. Thanks, Steve. Yeah, I think as the goals of app dev are shifting and as the way that we're building those apps are also shifting, that's largely a response to those changing needs and the changing expectations on app dev. And I think of DevOps as certainly an important part of that. I've seen DevOps compared to assembly lines. I like the way it's talked about as a kind of culture, but ultimately it's about closing the feedback loop with users and about giving teams responsibility for driving and delivering their own work. And now on top of those shifts in the practices, organizations are also making shifts on the technical side and moving to more architectural models that support a lot of the goals that Steve just talked about. Now, microservices are one way of doing that, and there's lots of reasons for adopting microservices. I'm sure Steve and I could talk for a long time about that. But I think really the only reason that you should be adopting microservices is to really allow your teams to move more quickly. I think there's, I think right now microservices, there's a little bit of a backlash. There's certainly a lot of mistakes that you can make when going about adopting microservices. But even if you're doing it right, I think really you should be focusing on velocity and productivity as sort of important concerns. Along with that, there's a bunch of other associated technologies like containerization, Kubernetes, that are really about enabling app devs to worry less about the underlying infrastructure. So that's great. And I think, in addition to microservices, there's also an opportunity to leverage a lot of other managed services that might be handled outside of your organization. And I think that's a shift. And, when we talked about outsourcing years ago, it was really about development and creation of the software, but now we're talking about outsourcing as delivery of the service itself. So that could be something like storage or load balancing, something that you might, if you're already in the cloud, you might look to your cloud provider to help you with. But there's a lot of other parts. That could be something like SMS messaging or voice communications. It could also be really things that are quite high kind of on the application stack. It might be something like fraud detection or something like payments. And like I said in the past, when third party was about building the software, then that was really a supply chain quality concern, making sure that you had the right testing in place. As we're shifting to this being part of the service itself and part of something that's critical to delivering that service to your users, it's really about that service quality instead. So all of these things together, these are all really ways, I think, of addressing the things that Steve was talking about. And in particular, these are really ways that we can accelerate delivery by decoupling the different components of our service, right? So we've decoupled the services themselves. We've decoupled the deployments. We can make changes to those services independently. And ultimately, that means that we've decoupled the teams as well, right? So, you can think of an application like what's shown here kind of on the left-hand side of the slide as a set of interconnected services. And this is often, used as a way of showing just microservices, but really there's lots of ways to build these independent layers. Like I said, that could be things that range from a mobile app or a web app at the top of your stack through some infrastructure that your cloud provider is giving to you, as well as the services themselves, and finally underneath some managed services. But really, again, this is about building independence and where you're again deriving value from the independence of those things. So if you've done that right, and you've decoupled those things, well, you've made your teams more independent, and you've maybe taken a step in terms of improving productivity and velocity for your organization. But there are some risks in doing so. And the big one is that you and your teams will lose the ability to see the big picture of what's happening in your application. Now, there's really two parts of this problem. One of the things is that decoupling has changed the rate of change itself throughout your application. There's many more teams that are deploying every day, even, especially if you're moving in a very agile process. And you've handed the responsibility to all of those teams in order to understand the quality of the software and manage it and monitor it as well. The second part of the problem is a little bit more subtle. So I always cringe a little bit when people talk about these systems just getting bigger. Our industry has built a lot of big systems before, or just that they're getting more complex. But I think there's a real way in which these applications are changing as a result of these both process and technical changes, and that's that they're getting deeper. What I mean by deeper is, again, what I'm sort of trying to illustrate with this picture here. The idea that we've split the application into these independently managed layers, right? So you don't necessarily have a single team that's responsible for all of them or responsible for operating all of them. And at the same time, we've made it so that a single user interaction, a single transaction, might depend on the whole thing. And that depth is important. It's not just about, like I said, about getting bigger, but it means that we have a need for not just like bigger tools or more scalable tools, but really different tools in a lot of ways. And I'll talk about that more in a second. The other important part of this diagram, just to think about, is that team is effectively responsible not only for their own layer, but they're also responsible for all of the layers that are below them. That is, that the quality of their service will depend on the quality provided by those below them. But they can only really control their own service, right? That's the only one where they can really, push out new code, roll back, things like that. And the services below them, the cloud providers, others are making changes independently of them. And likewise, they can't control, what's happening above them as well, right? They can't control which version of a mobile app a user is using. They can't control changes that cloud provider might make in terms of a load balancer or something like that. And this, I think, I said that a lot of the changes here we're thinking about in terms of improving productivity. But what we're also doing is we're giving devs responsibility without the sort of associated control. And responsibility without control is sort of the definition of stress. So I think there's a real risk here from a people perspective as well, that we're actually, not just in terms of metrics like, number of deployments and things like that happening, but just from a real happiness and sort of satisfaction point of view. So
Spoons, I was just going to add, though, that it feels to me like scalability is the big challenge in all of this, right? Scalability from the standpoint of the number of different services that ultimately make up your application in terms of, and then kind of the unpredictable scalability in terms of what services get invoked and how you scale the application up and down, as you said here, asymmetrically. So it feels like that's the root of, sort of largely the root of the problem. Do I have that right or not?
That's certainly a big part of it, I think. That the way that different parts of the system need to scale differently. I think there's a little bit of a tangent, but one of the ways that I've seen these kinds of tools used in organizations like Google is not only just from the point of view of there's an incident, I'm trying to understand what's broken, but trying to do things like long-term capacity planning. And trying to understand how each of the components of this thing needs to be scaled up over time as both user behavior changes, as new features are rolled out, and not understanding the connections makes that almost impossible to do that kind of long-term planning.
Okay, got it.
Yeah, so I think the other kind of challenge here is in thinking about kind of the foundation of this monitoring and observability, and that's really comes from the telemetry, from the data itself. That also needs to change. I think when organizations and when these pieces were a little more siloed, each team could kind of define which aspects of the telemetry mattered most to them. So for a database, to be concrete, maybe it was the type of statement that mattered. For a load balancer, which upstream system is the thing that matters. For a mobile client, maybe it's which platform it's running on or something like that. But those aspects are the things that for each of those teams is really going to help them understand performance and other kinds of problems. But what's changed is now every component depends on all of these other components, and those aspects of telemetry are now also interrelated in a way. So that means it's not just a matter of amalgamating all of this telemetry together into one place, but making sure that it's really can be analyzed across all of these different dimensions, these different axes that are present across the application itself. I think that's kind of a big change from where I think folks have thought of before, where again, it's not just a question of getting bigger or scaling up, but also in this sort of the richness of the data in a way, and the ability of a system that's looking at that data to understand that.
So does this come down to just understanding the dependencies that make up the application? Is that the key to all of this?
I think that's one really, really important axis. I guess the kinds of things that I've seen and talked about with folks at times is like, even for a system, I think I worked on at some point back at Google where, within Google Cloud, there's a lot of different components to making Google Cloud work. And my team was often at this sort of kind of crux where we would get alerted or hear from users that there was a problem, and certainly understanding which which upstream system was responsible was a big part of that. So understanding our dependencies was important, but also understanding the changes within those dependencies, right? So which of those has done a rollout, which of them has just, scaled up or maybe needs to scale up and things like that. So I think kind of looking across all of these different dimensions, across all these different axes is pretty important. So I realize we've gotten pretty far actually without really defining observability in a way. I think, there's, as a fairly new term, I think in the industry, we're still kind of coming to grips a little bit with what it really means precisely. I think a lot of folks talk about observability in terms of these three pillars that, if you've got metrics, if you've got logging, if you've got distributed tracing, then you've got observability. And I think, there can be some truth to that. That really came from places like Google and like Twitter. But I think the thing that I would caution folks here is that when you're hearing about tools like coming from Google and Twitter, that's really like, those are the implementers that are telling you about. That's really coming from the perspective of who's providing that solution. And we're not hearing about these tools from the app devs in those organizations. So I think if you actually went and talked to the app devs, they would give you a pretty different perspective. I think one thing that I took from my experience there is really the connections between these tools that's important. That was really where we saw them being really leveraged and really where the devs were getting a lot of value out of them is when there was an integrated approach to observability. So I think that's to say, like, it's, I wrote here, it's at the intersection of the telemetry of these things like metrics, logs, and traces, and with that, analytics and policy on top of that to solve real problems. I think, the other part of that is really looking at those use cases, right? So the way that I like to think of it is that observability, I think like Steve is saying, it's sort of an important part of manageability. If you don't know what's happening, you can't take the right actions. And so a big piece of it is really being able to navigate from effects back to the causes of those. So, root cause analysis is certainly kind of a key example of that sort of thing. But, there's other places where not just responding to an incident, but you might be planning long-term optimizations, or you might be looking at reducing costs in some way. Observability is key to that. And it can also be something as simple as just pushing out a new release and knowing if that's a good push or not. So again, kind of going back to the use cases and looking about how maybe not the three pillars of observability, but maybe three pillars of telemetry itself and how that data can be fed into a unified analytics system. I think, there is a lot of data there. I think, we see folks when I've talked about observability and how people are approaching that, trying to apply tools from sort of other nearby areas. So a great example is looking at a logging tool. We all use logging for a lot of different reasons, but applying the same logging tool that you might use for something like revenue tracking to observability is going to be, I think, pretty painful, mostly because the volume of data that you need to collect in observability is so much higher. And at the same time, the value of that data is not nearly as great. And the observability side, it's really about extracting patterns. It's not usually about the individual cases, where, of course, on a revenue side, each of those ones matters. I think another important part that we've heard from folks is using the right way to get the data out of your application. I've participated in a bunch of different work to do this in an open and standard-based way. The latest version of that is called OpenTelemetry. It's part of the Linux Foundation's Cloud Native Computing Foundation. And that's really an organization that helps folks understand and helps drive the community around things like Kubernetes as well, and a place for folks both from the implementer side, folks like me working at Lightstep, and also folks from the user side who are interested in using these kinds of things to come together and to agree on a set of APIs that they can leverage, independent of what vendor they ultimately end up going with. As part of extracting that data from an application, it really needs to happen early in the process. I think this is a thing that's shifted a bit in the last couple of years, largely due, I think, to the depth of these systems. When you had a more monolithic application, it was possible to extract a lot more of that telemetry automatically. And while it doesn't have to be a lot of work, it has to be done in a way that's a little bit closer to the application in a lot of ways. And that's where an open source API like OpenTelemetry can be important. And then, if you're going to get value out of this thing, it's really got to integrate with existing workflows. I really like to say that, what matters for development tools is how they can be used by teams, not just individuals, but the teams themselves. So how does it integrate with their practices around planning their work, around testing, around deployments, around their processes, around things like on-call and incident resolution. So I wanted to talk a bit more, kind of at least how Lightstep approaches this. And I think there's kind of a high-level picture here. Like even if you end up deciding that Lightstep's not the right solution for you, I think there's still kind of a framework that you can take away to think about the different pieces that go into an observability solution. So one side of that to touch on first is just how do we collect that data itself, right? That's the foundation I said of doing observability, is having the right data. I talked some about open source and OpenTelemetry. One of the advantages of that is it means that we can also integrate quite tightly, not only with our customers' proprietary software, but we can also integrate quite tightly with open source software, whether that's a message bus or a pub subsystem, a storage system, an SDK that you're using for some other piece of software. Those are all places where OpenTelemetry can be plugged in tightly and where we can get the most meaningful data for your application. One of the big things that comes up, I kind of alluded to this a little bit in talking about logs, but really doing this data collection in an efficient way. Just to get sort of a reasonable value for that cost. One of the things that we found when we did this at Google, so Google did a lot of, almost all of its, observability and telemetry collection was done in production. And Google at the time was handling billions of requests every second. In order to make that cost effective, they did a bunch of experiments. And one of the things that was sort of interesting was it wasn't really about impact on the application that was important. The experiment showed that even for something like web search, which is an incredibly high throughput and latency sensitive service, that the impact in terms of like what a user would observe was quite low, even when it was on essentially all the time. On the other hand, one case where there was a big impact is that the amount of data generated was quite expensive, both in terms of a storage and a network point of view. And so there was the approach that we took at Google was actually to sample down the data. And I think sampling is a topic that comes up a lot in observability, kind of around this bullet. In that by throwing out, it turns out 99.99% of the data, we were still able to get a lot of value, but bring the network and storage costs back in line with the value that we were getting. I just wanted to mention it briefly here, but I'll talk about it again in a second. But using service level agreements, objectives, and indicators as a way of not only measuring, how well your organization is doing in terms of setting and meeting goals, but thinking of those as something that can actually drive the telemetry collection process itself is pretty important. So that's to say, like, your team should be doing work, right, to improve their SLIs and meet their SLOs. Your telemetry solution should also be using that same data to make decisions about what data it's keeping and what data it's not. And then finally, I think a big part of observability and deep systems is really about building context and putting data in the context where it matters or not. So a particular database call might not be that interesting until it ends up being part of a transaction that fails, and then suddenly it is something that's really relevant to a dev that's trying to understand what's going on. And as part of that, using that context to drive feedback within the collection system itself. So that can mean focusing on different kinds of data. It can mean sort of changing how sampling works in a way. So to give an example of how Lightstep does this, Lightstep's constantly looking at where deployments are happening within an application. And whenever we see a deployment, we are able to turn up the volume essentially for that service both collecting data from the old and the new version. But we also want to turn up the volume for any other services that are participating in the same transactions, any other services that are affected by that new deployment. And that's kind of where this context comes in and is important, because it actually might be that that deployment's fine from that team's point of view, like everything looks great. But for one of the downstream systems, it actually might not be great at all. And so collecting the data of how that team is performing is really important. So you can think of all of this collection as really kind of about managing costs in a way, right? The data itself is only going to be valuable in terms of how we use it. And it's a liability in a sense, right? We have to store it, we have to transmit it, things like that. So then on the other side, once we've got the data, we need to do something with it. So like I mentioned, deployments is an important part of how we think about using Lightstep. Deployments are something that developers are doing every week, if not every day, or aspiring maybe to do them every day. And understanding when a deployment has worked, it can be one of the more stressful moments for an engineer, for a developer working in a DevOps environment, right? This is the moment when they're getting that feedback from users, right? They're understanding whether or not it's working. So that's certainly an important use case. We think a lot about using that data to help resolve incidents, right? This is another really stressful moment in the life of a developer. Again, especially for someone in a DevOps shop who might be carrying a pager, just got woken up, it's 3 in the morning and needs to figure out what's going on. And again, the context is really important in that situation as well. I kind of think of what Lightstep does as it's sort of like an automated assistant to kind of like a crime scene detective, right? So as a human that shows up there, you sort of want something to put the most important clues in front of you so you can make a decision. You can bring your insight and your experience to that, but you don't want to go through and fingerprint every surface in the room. You want an automated assistant who's going to come and find the most important parts and not give you reams of evidence, but give you the 5 best theories that it has about what might have happened, and again let you use your insight to understand what's happening. And then I think the last one, that sort of operationally looking at cost and performance within the application itself. So as a team looks and sees where maybe they could be improving their performance and how they're planning that work. We saw examples at Google where a team would go off and you can think of web search as a pretty complicated system that spanned a big part of the organization, and right, because you type a query into Google and you're seeing web results and images and videos and news and all kinds of different sorts of results. And one of those teams might go off for a month and do a bunch of optimization work. And it turns out that didn't matter at all, because as far as the end user is concerned, that wasn't the bottleneck, right? And so using observability data to understand where the bottlenecks are, not in individual transactions, but across whole sets of transactions. At Google, we did this by looking at a sample of all of the web search requests over the last week, billions and billions and billions of those, and looking at where the bottlenecks were, and then letting those teams know that they were the ones that could really make an impact, and giving them the data to do that. The machine learning capabilities here really come in, I think, in terms of putting the right evidence forward. In a deep system, the number of things that can go wrong, is really corresponds to the number of connections between these systems. And so really, I think the automated processes here need to find out which are sort of reasonable and which ones are just not relevant for what's happening. And I think as part of that, it's really a question of using that context to understand where there's correlations within the system. So, there might be lots of different changes within a system, lots of things that are breaking all the time. And whether or not those things matter is really something that a computer can decide. And that's really where I think ML can play a strong role. In terms of, what constitutes an anomaly or what can go wrong, I mean, really this should kind of come back to the things that matter to your end users. So looking at really driving this process from your SLOs and SLAs, and understanding what your users are depending on, and how changes within your system are driving that. And then finally, there's a bunch of ways that we can use observability to actually set policy, and whether that's through things like alerting rules or reporting, that's a way for us to, and for users of the system to really use observability data to inform decisions made by their organization. So I think, overall, these are really all about understanding those changes, about driving resolution, whether that's a regression in terms of something that's been rolled out, or whether it's a change in user behavior. And then doing that at a cost that's reasonable, right? And that makes sense given the value that you're getting from that. And that really demands an approach that uses this sort of machine learning capability and a dynamic collection and a responsive collection process to do that at a reasonable cost. So in thinking about how to adopt a new observability solution, or even to adapt and to grow what you have today, I think really thinking about the kinds of practices you have in place. What are the DevOps processes that you've already put in place? What are the ones that you're thinking about adopting in the near future? What are the technical and architectural changes that you've made? And what are the ones that you're planning on making? Because those, I think, are really important pieces of understanding what will be important in an observability solution. If you're looking or started down the journey towards a microservice-based application, or maybe you're just leveraging a lot of different managed solutions, then really you have a deep system, and having a tool that can support a deep system, I think, is incredibly important. In order to do that, that's going to take a unified approach to data collection. Like I said, it's not enough just to have a metrics tool, a logging tool, and a tracing tool. It's really, I think, key that you have a single tool that can ingest all three kinds of data and derive insights from those things. And then I think, Steve and I mentioned briefly that there's a lot of different ways that you can sort of slice and dice this data. Whether that's what particular version of the software is running, what platform a user is running on, what kind of query was made. We really need to be able to organize this data in a non-hierarchical way so that the devs responsible for these systems can ask lots of different kinds of questions. And so that the automated systems, the ML systems behind it, can also ask those kinds of questions. Tools absolutely have to put golden signals, things like latency, error rate, and throughput at the forefront, and put the user performance as perceived by your end users at the forefront of how you're measuring performance, and then using the rest of the telemetry data to put context around those sorts of things. If you're going to be using this to do something like monitoring a deployment, you absolutely have to have a real-time analysis. And that's you don't want to wait 2 hours or 24 hours to understand whether or not a deployment was successful. You want to understand that within minutes, if not seconds. And I think that part of that real-time analysis can also support a lot of shift-right work, moving things back into the CI/CD pipeline, using observability to understand failures within that pipeline, to trigger on those things and give devs the context that need to understand what those failures were so they can solve them quickly. At the same time, I think within DevOps, we also see shift left, especially given the complexity of these systems, there's no way to represent that complexity anywhere outside of production. So ultimately, whether you like it or not, you're going to be doing testing in production. Even if you could, which in many cases, folks can't build things at scale to do that kind of testing in a QA environment. But just the number of different variables that you would have to get right is just too large. In terms of the way that we have seen observability tools deployed, part of that really needs to come from the teams themselves, and they need to be able to get value from it. So it needs to be easy for an individual team to implement a tool and to get value from it. And that's where we've really seen the most success in folks adopting this sort of new generation of observability tools. So picking a team or a small number of app teams that are really critical to the business. We've also seen folks kind of try to pick something over on the outside and do an experiment. And it doesn't help build a kind of poster case or a poster child or a case for why this needs to be deployed for the rest of the organization. So pick something that's small but critical and in the critical path, deploy it there, figure out how that observability tool can really work within your organization, and then use that as a kind of template to sort of stamp out across the rest of the teams. And then finally, these tools really have to, provide ways to adjust your goals, whether they're SLOs or other kinds of goals, in both supervised and unsupervised ways. So that means both that has to have the data that your teams can look at that and understand where there's an opportunity for improvement, where it would make a difference. And they need to be able to suggest ways as well, looking at the sort of correlated data and understanding how changes could actually have positive impact on SLAs and things like that. So, yeah, I think I'm going to hand it back to Steve here in thinking about, how do we understand where we are going to be along this journey.
Hey, that's great. Thanks, Spoons. So the first question here is, how important is microservice development going to be to you going forward? So I think I already know the answer to that question, and the research that we've done recently showed that containerized workloads were going to grow 38% in just the second half of 2019, which is actually an astounding number. So that's pretty much on the the cusp of 100% over the calendar year 2019. And we haven't asked that question yet in 2020, but I suspect it's going to be gaining momentum. So I think the answer to this first question is that, by and large, microservice development, certainly at large organizations, is going to be especially important. The next question here is to ask if your current approach to operational analytics supports deep systems. This is especially important because many established vendors are finding that their current data models for data management cannot really align all that effectively with the added dimensionality of deep systems. So having the right data model for data collection is certainly a prerequisite to supporting effective data capture and analysis of what's going on inside of deep systems. The third and fourth questions here are, how complete is your observability solution? Because there's effectively no limit to the analytics and governance that vendors can ultimately provide in observability, this is actually kind of a hard question to answer. However, what we can say is to reiterate the importance of multidimensional data capture. This is because the limiting factor to analytics is the quality of the data. That said, a priority for observability is certainly real-time insights into anomalies. Spoons was very clear on that. And this implies finding a way to reduce or eliminate false positives, which I don't think we talked about much, but certainly enables sophisticated alerting to deal with these anomalies when we find them, and do that in a very timely and nuanced way so we have the information we need to be able to resolve issues. So there's obviously additional room here for predictive analytics, for optimization and governance, and AI and ML, and all of this supporting a progression of capabilities from supervised to unsupervised manageability. So to wrap this up, I said the last question. I have one more question here. Last question here is, how cost-effective is your current observability solution? Well, cost will depend a great deal on the volume, the variety, and the velocity of the data that you're collecting. Cost will also be influenced, of course, by the complexity of the analytics being performed. Spoons talked about all of this. SaaS solutions might help vendors manage cost, but really, at the end of the day, it's not so much just the overall cost that matters. It's the value that's being provided by the solution relative to its cost that matters the most. Okay. So to wrap this all up, we know that cloud-native and microservice-based application development does lead to complex applications and topologies and deep systems. Managing these deep systems effectively requires metrics, logs, traces, and open telemetry in order to make this data collection process easier. Observability, which is really the intersection of data and analytics and policy, is really difficult to do well for deep systems. Therefore, it's really important for vendors in this market to have a robust data model and methodology behind their observability. While observability is largely focused today on anomaly detection and root cause analysis and continuous improvement, it's really not hard to see how observability will lead to governance and more optimization over time. Clearly, AI and ML technologies are really the future of observability here, as they are across much of what's going on inside of DevOps. So overall, I guess I'd wrap this up by saying that while monitoring has been a mainstay of managing production systems, changes in how we develop applications mean changes in how we manage these applications. And making sure that your observability solution is up to the task of managing complex microservice applications is one of the most important things you can do to improve your software development lifecycle. Okay, so with that, let's move on to questions and answers, part of this webinar. And Raleigh, could you once again guide us in terms of how we do this?
Sure. Thank you, Steve. Before I dive into questions, I wanted to invite the audience to check out Lightstep's interactive sandbox. You can go to the URL listed here on the screen to find out more, and I will also include this in the follow-up email. If you have questions, you can log them now. You should see the Q&A box in the left-hand side of your screen. Spoons, there are several questions for you. The first is, how does Lightstep determine what transactions or activities will be monitored and to what level of detail?
That's a great question. So there's a couple of different ways that we approach that. One of them is that at some level we're monitoring everything. So Lightstep sees 100% of the telemetry data that comes from the application, and it can automatically look for patterns within that data. Of course, we also use input from our users as well, so they can identify things that matter to them. That might be a key transaction or a key service within their application. And then once we've identified those things, we measure things like latency, things like error rates, to then further drive that process. So when we see errors, we'll certainly grab those transactions. When we see slow transactions, we'll grab them as well. Of course, we'll also grab some fast ones to provide context for what makes the slow ones different. And then within those transactions, we'll look at what's happening sort of across the stack and pull in telemetry data from not only the service that say had the error, but other services that participated in that transaction. Pulling that all that data together, looking for correlations that can explain changes in those metrics like latency and errors, and then presenting that information back to users.
Great, thank you. And can you also discuss, when looking at baselines and regressions, how does Lightstep avoid generating lots of false positives?
Yeah, so when, I guess, in a way, we're collecting data all the time. So collecting data is not, a false positive or not in that sense. I guess what we look for in terms of a regression is really something that matters in a way. So, we can look at not only that, say, the median latency has changed, or even that a high, like something like 99th percentile has changed, but because we're looking at all the data, we can actually look for this is a little bit hard to describe in words, but changes in shapes of the distributions themselves that really represent changes in behavior. Maybe this is getting a little bit into the AI ML components of what we're doing, but really looking for things that are even hard sometimes for humans to understand, where there's differences, and using those to identify those regressions. I think part of that is also looking where there's correlations within the application, because a lot of times you'll see many changes that are all sort of driven by the same root cause, and that sort of consolidation can also help limit this issue.
Thank you for those insights. Steve, let's jump over to you. Where is the operational analytics market headed?
Well, I guess I see a couple of ways to answer this. First of all, we are making this transition to microservice-based application development. The growth rates I cited about just increased microservice adoption clearly shows that. I think the reality is that microservice adoption is accelerating so rapidly. I'm a little nervous as to whether or not observability solutions have been are a high enough priority at this point in time, so that organizations may be caught a little behind the power curve in terms of being able to manage what they're actually developing. From the standpoint of another trend here, finding a way to leverage AI and ML so that you can shift more from being sort of reactive from the standpoint of how you are looking at observability to being more proactive, I think that has a lot of interesting potential. We didn't really talk about optimization, but optimization, actually, mathematical optimization has been around for a while. But I really think that optimization is really cool because in this kind of a context, once again, this is the analytics based on the observability. A lot of opportunity here through optimization to basically minimize or maximize an objective function like, how should you configure things to drive better performance or reduce cost or minimize risk or, meet your SLOs. I think that is, that's going to come for sure from the standpoint of where we're going. Increased role of policy layered on top of observability, I think is really important because that conditional logic that we define in terms of business rules really does drive who the organization is because it kind of governs what policies and what the actions the organization takes. So an increased emphasis on policy, I think, is going to come along, which will better position enterprises to deal with governance issues. So those are kind of the top of my list.
Great insights. Thank you. Spoons, jumping back over to you, do AI and ML influence how Lightstep operates? And if so, is this done in a supervised or unsupervised way?
Yeah, that's a great question. And I think I covered this a little bit. It's done in sort of a combination of those two ways. In some cases, we are leveraging input from users to do a more sort of supervised learning. But at the same time, we're also, a lot of the correlation analysis we're doing is largely more independent of that. But I think, ML AI is taken quite a while, I think, to get to observability. I think that's partly because there's a lot of insight that the humans have to bring to the table in this case. And I think these systems are just complicated, and the kinds of changes are not predictable enough that it's been a while kind of coming to get to this point.
Thank you. And given the random nature of how customers can navigate a deep system, how does Lightstep know what the complete topology of a deep system or application is?
Yeah, that'll really come down to the quality of your instrumentation and to the quality of the data itself. So, I mean, Lightstep or any other observability solution really can't go beyond what's there. The way that we think about it is because we can see 100% of the data, we can make sure that we find all the connections that are there, even if they're rare or, they might be drowned out by a more common kind of transaction.
Great, thank you. And to wrap up today's event, Spoons, can you talk about what's on Lightstep's roadmap?
Sure. Yeah, so we've recently announced features that integrate metrics into our product. Those are ways that, and not in a way where you have, two tabs or two windows or something like that. It's a core part of what we provide, and it's tied in with the other kinds of data that we collect. We're looking at ways of better supporting things like SLOs going forward. We've got a lot of interesting things happening on the automated analysis side that I'm pretty excited about.
Great, thank you. And I wanted to thank our audience for taking time out of your schedule to join us today. As I mentioned, you will be receiving a follow-up email from EMA that will include resources from today's webinar. So I hope you will check that out. And I hope that we will see you at a future EMA webinar. Thanks again for joining us, and enjoy the rest of your day.